Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is dedicated to college algebra students who are just kind of going into the beginning of college algebra and need a review of equations. I've broken this into several sub-videos just so you can pick the topics that you specifically need to review. But this one is dedicated to a 30,000-foot view of how you're basically going to approach solving all equations from this point forward. So just to remind you, you've probably solved the following styles of equations: linear equations, quadratic equations, rational equations, radical equations, exponential equations, logarithmic equations, absolute value equations, equations involving rational exponents, essentially any kind of equation out there that does not involve trig functions. So I'm going to read this paragraph here because this is kind of important. Now that you have significant experience solving pretty much all basic equations in mathematics, it's time to pull the concepts together. You probably learned to check your solutions when first learning to solve equations, like when you learned to solve linear equations or something like that way back in middle school or elementary school. You had to check your answers. But that gets really tedious as we move forward into advanced mathematics because your answers get very robust. They're not likely to be clean answers like 5 or -2 or something like that. They're likely to involve radicals and pretty ugly answers, actually. So at that point, you just need to trust your mathematical prowess and your abilities to use tactics like removing extraneous solutions and whatnot. So assuming that your mathematical manipulations are reliable, the only things you really need to watch for when solving equations are the domain of the functions within the original equation and the range of those functions. The reason why those are the two things you want to watch out for: the domain of functions restrict what you can plug in to those functions, and the range, well, that restricts what the outputs can be. And you'll see me use this tactic when I'm solving any type of equation from this point forward. Here's a list right here of the common functions that you would have encountered so far that have restrictions. For example, linear functions and cubic functions, stuff like that, those don't really have domain or range restrictions. However, radical functions with even indices, including equations with rational exponents, well, those do have some restrictions. And let me just remind you what I mean by radicals with even indices being involved in equations. It would be something like that. Both sides of this equation have radicals with even indices. If you're missing an index, obviously that's just going to be a second index right there. So there is a restriction. The first thing that you have to note is that the argument of any radical with an even index, which by the way we would call the radicand, must be greater than or equal to 0. So in this case, that 3x plus 1 is already restricted. It has to be greater than or equal to 0, which tells us that once we're done doing all our manipulations, x has to be greater than or equal to a -1/3. If we get an answer that's not greater than or equal to -1/3, it's called an extraneous solution and we could throw it out. Likewise, on the right-hand side of this, we have the second root of x. That means that x itself must be greater than or equal to 0, and that supersedes the x being greater than or equal to -1/3. What I mean by supersedes, I mean, really, if x is greater than or equal to 0, it's already greater than or equal to -1/3. So that highlighted restriction is the more, well, restrictive restriction, I guess you could say. So that's something you need to watch out for when you're working with equations involving radicals with even indices. The radicand must be non-negative. And so I generally make that note before even starting to solve. That way I just know here are my restrictions. So when I get to an answer, I'll just look back at those restrictions and ask myself, does my answer satisfy those restrictions? If I get an answer like x being -3, that's a problem because x has to be greater than or equal to 0 here. Something else you should note about equations with radicals with even indices is that the range of an even indexed radical is not negative. That is, if you have the fourth root of x, let's just say, that, whatever that value is, has to be greater than or equal to 0. So if the original equation was the fourth root of x is equal to a -3, I know there's no solution because the fourth root of x must be greater than or equal to 0. Even indexed radicals always return non-negative values. So that's kind of things I look out for when I'm working with radicals with even indices. Odd indexed radicals involved in equations, well, there's no restrictions there. You could take the odd root of any number that you want, and radicals with odd indices can return any value, negative or positive. So there's no restrictions on domains or ranges when your radical has an odd index. Now let's talk about rationals. There are no real range restrictions. Well, that's sort of not true. There technically are range restrictions with rationals. However, that's not really a major focus or a major concern, but there are domain restrictions with rationals. So let me give you an example of a rational equation. I'll actually use this same area right here. And I'm being very, very loose with my definition of a rational equation because technically a rational equation should be an equation involving ratios of polynomials. However, that's not always going to be necessary to think of it that way. In this case, you have a ratio of polynomials in your very first fraction, but the second fraction is a ratio of a polynomial to a logarithmic function. But still, the conversation is going to be the same. With rational functions within equations, you want to make sure that those denominators are non-zero. So the very first thing I'm going to state here is that this denominator right here cannot be 0. And we know from years of algebra that we just factor that'd be x plus 2 times x plus 3. That cannot be 0. Therefore, neither of those factors can be 0, which means that x cannot be a -2, and nor can x be a -3. So if I go through and solve this equation and end up with an answer of x equals -2 or -3, I can look right back at the beginning where I make this statement of what my answers cannot be, and I take a look at that and I say, oh, well, since I got an answer of x equals -2 and x actually can't be a -2 because it would cause division by 0, I throw out that answer. However, there's actually an additional restriction here. This denominator also cannot be 0. This tells me that x cannot be e to the 0th, or in other words, 1. But there's an additional hidden restriction here because not only can that denominator not be 0, in other words, x cannot be 1, but it's also the case because you have a logarithm there that the argument of that logarithm must be positive. So there are two restrictions on that denominator there. X cannot be 1, and at the same time, x must be greater than 0. So when you combine all of these restrictions, that x can't be a -3, x can't be a -2, oh, by the way, x must be greater than 0, and it can't be 1. You combine all those restrictions and you get the following, that x must be in the interval from 0 to 1, not including 1, skip over that one, and it could be any value from 1 to infinity. Now, am I saying that that's actually my answer? No. I haven't even begun solving this. But the idea is whatever solution I get has to be within this interval. If it's not, it's called an extraneous solution. So that's a review of rationals. And that's actually the only video that I don't review for college algebra because you've been solving rational equations for such a long time and they don't really change how you solve them. So it's not that big of a deal. If you need that type of review, you can look in my intermediate algebra videos or my elementary algebra video sets on how to solve rational equations. Let's go ahead and take a look at the next styles of functions, and I'll just group them together: exponentials and logarithms. So exponential functions, well, they don't have domain restrictions. So if you have an equation involving an exponential, like 2 to the x equals some number. I don't really care what the number is right now. X can actually be anything. So our candidates for what x can turn into could be any real number we want. However, you have to be very, very aware of the range of exponential functions. The range of an exponential function is positive. Thus, if the original equation wasn't 2 to the x is equal to some arbitrary number, but instead -3, I know there's no solution because exponential functions do not return negative numbers. However, if that was for example, +3, then I know that I have to go through and solve that equation because, well, exponential functions can return positive numbers. And then logarithmic equations involving logarithms. So the range of a logarithm is all real numbers, so you don't have to worry about that. But the domain of a logarithm, it only includes positive numbers. So if you're working with an equation and your equation looks like, I don't know, something like this, then I know that in the end, whatever answers I get or whatever answer I get, it has to be the case that x minus 2, the argument for this logarithm, has to be positive. That is, x must be greater than 2. And also the argument for the next logarithm in line, which is x plus 1, that would also have to be positive, which tells us that x must be greater than -1. Of these two restrictions, the tighter restriction, or the one that kind of supersedes or contains the other restriction, is the x must be greater than 2 restriction. So all values that are greater than 2 are also greater than -1, so that's the restriction that I'm going to stick with. If I only stuck with the bottom one, this x being greater than -1 right here, that allows an answer of, let's pretend, x equals 0. But I can't plug in x equals 0 into that very first logarithm. It would cause us to have a negative as an argument for our logarithm, and that's illegal. So you always take, with logarithms, the tighter of the two restrictions. So again, this is just a heads up when you're working with any type of function, equation that involves these types of functions, always try at the beginning to state what x must be or cannot be. Finally, and what's more important to us as we move forward in mathematics, is absolute value equations. Now think about an absolute value, and let's throw that into an equation form. So let's say we have the absolute value of x squared plus 3x, and absolute value is equal to some number. It doesn't really matter. Let's just leave that blank for the moment. Well, absolute values, you can plug any number you want into an absolute value. So there are no domain restrictions on absolute value functions. Therefore, from the get-go, I'm not really too worried about what x is. However, when looking at the equation, I do want to note what the output of the absolute value must be. It must not be negative. So if somebody handed me an equation, absolute value of this ugliness is equal to a -7, I immediately know there's no solution, because absolute values never return negative numbers. This very holistic view of solving equations, or beginning to solve equations, is very, very powerful as you move forward. It gives you a very natural understanding of the behind the scenes motivations of why there are solutions to some equations and why there are not solutions to other equations, and what you should always be doing as you're solving equations, looking for realism. Now that's pretty much all I wanted to talk about in this video for the 30,000 foot view. What we're going to do in the next video is start going into a review of how to solve specific styles of equations. I'll see you there.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Listen close, don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.